In this video, we're going to look at conventional loans and solve using the TVM calculator. Identify the givens and the goals in each problem and write your final answers as complete sentences. So we're told you make car payments of $421.76 per month. If the APR is 7.23% for 5 years, here's the question. How much did you borrow for the car? Okay. Then we're also asked, how much will you pay in total for your loan, including interest? So first, let's fill in the information we know. Now, we're thinking of this like an annuity, but we're kind of reversing the direction of payout and savings. Okay. So the present value is actually how much you received when you borrowed money for your car. Okay, because at the beginning they give you a whole bunch of money, they pay for your car, and then you pay it back. So the present value is what we're looking for. Now your payment is $421.76 per month. Now since you're paying this out, this is going to be negative, so negative $421.76. The future value of the loan, when it's all paid off, you will owe $0. Now your interest rate is 7.23%. The number of payments is going to be 5 years, and you're making 12 payments per year, and 5 times 12 is 60. And then we're going to think of this last box as a pay period, which is the same as the payments, which is monthly. So now let's use the calculator to find out how much the initial loan was. So first, the present value, remember that's what we're looking for. Your payment is negative since you're paying it out to the bank, so $421.76. The future value is that you will eventually owe $0. The interest rate was 7.23%. The number of periods was 5 years every month, so that was 60 periods. And the pay period is monthly. Okay. Now we're solving for the present value. Okay. So you borrowed $21,183.44 for your car. So let's write this first result as a sentence, then we'll answer the second part. So the question was, how much did you borrow? And we will write, you borrowed $21,183.44. Okay. Now let's look at the second question. So it asks, how much will you pay in total for your loan, including interest? So notice, this isn't really what you paid for your car. This is what you borrowed. What you end up paying is this monthly amount, and remember there was 60 payments. So let's compute this right in the middle here. You will pay 60 payments of $421.76. So we need to multiply these two values, which we can do on a regular calculator. 60 times 421.76 equals $25,305.60. So $25,305.60. Okay, so now let's write that as a sentence. We weren't asked for the interest you paid, but notice it's a little over $4,000 would be the difference from these two. Okay, so you paid $25,305.60. Let's look at the next one. Okay, this is the same idea, except now we're purchasing a home instead of a car. So let's highlight the given information. You borrow $340,000 to purchase a home. The interest rate is 6.5% and the loan is for 30 years. And you are asked, how much will your monthly payments be? So this is our goal. So now let's fill in these values. So at the start of the loan, you are given $340,000. Okay, so since you are given this, it's going to be considered positive. Your payment is what we're asked to find. So I'm going to put a question mark there. At the end of the loan, you will owe $0. Okay. The interest rate is 6.5%. Now you're making monthly payments for 30 years, so 12 times 30 is 360 total payments. And again, the pay period is the same as when you pay, which is monthly. Okay. So let's put this in the calculator and solve for the payment. Okay, so the present value of the loan, the amount you're given at the beginning, is $340,000. We're solving for the payment. The future value when you pay off the loan will be $0. The rate is 6.5%. You make a total of 360 payments, and those are monthly. Now we're solving for the payment. And we see that your payment, it's negative because you're going to pay it out every month, is $2,149.03. Now let's write our result as a sentence. How much will your monthly payments be? And we will answer your monthly payments will be $2,149.03.